This is Pwn appointment book. It says exploit the application to get the flag. We're given a download binary. If we open up the binary in Ghidra, there's only one important function, this create appointment function. And what it's going to do is there's a global array of appointments, and we're allowed to select an index between 0 and 8, and we can put in a message, which will be a malloc, and a timestamp, which is just a Unix timestamp converted into an integer and stored. So the appointments array has 8 entries, and each entry is 2 8-bit fields, one for the description and one for the timestamp. The bug in this challenge was they checked to make sure that the index wasn't greater than 7, so greater than the allotments of appointments, but you were able to supply a negative index. And so you could supply either a heap address or this timestamp down in this read-write section. So to see potential targets, what you can do is you can load it up in GDB. So we'll go GDB, appointments, we'll run it, we'll cancel. Let's print out VM map. Let's print out the address of appointments. And we can see the address of appointments is 4037A0. So this is in the read-write section of the appointment book. So we can take this and see potential overwrite targets. So we'll do maybe examine 100 hex at this address. We're looking for anything that has a known address. And so here we can see here's appointments all the way down here, and here's the global offset table. So what we could do is write an appointment with a negative index to somewhere like the exit global offset table handler. And what's going to happen is the timestamp is going to be saved, and then a heap address is going to be saved. The heap address, if remember, it's going to be some random address. It doesn't really help us too much, but if we were careful about how we constructed the timestamps, we could put in a timestamp that's actually an address to something else. So when exit gets called, this other thing will get called. If we go back to Ghidra, they thankfully gave us a win condition, and so that's kind of what we had to do. There was this function called debug remote, and so we're just going to figure out what this address is. It's over here, 401336. If we can figure out what this is in a timestamp, we'll send over that timestamp. It'll get parsed into the Unix time, which is that number. We'll set a negative index. In this case, would be -1, -2, -3, -4, -5. So we'll set an index of -5. We'll overwrite this exit handler, and then when we exit the program, our win function will be called instead. See what this looks like. This is the solve script. We're just importing standard stuff. I disable warnings. This is Pwn tools context, so we load in the ELF binary. We set the architecture and the bits here. We set the log level. I do terminal splitting because I use GDB within Docker. We didn't need libc for this process. We'll run it locally first. So first thing we do is we grab out the win address. You can do this by just loading in the symbols. So elf symbols remote debug. And so this will print out, if we go back to Ghidra, this address, 401336 in hex. And we also decided we want appointment index -5. Remember, we got that by just counting backwards. So this is 0, this is -1, -2, -3, -4, -5. So that's how we calculated -5 for exit. Like I said, we need to convert the timestamp from the Linux time to a string timestamp because that's what the program expects. And then from there, we just send over all this information and we should just win. So we can try running the script, Python 3, solve.py. And if we did it correctly, yep, we have shell. So at this point, we can try running it remotely. ls cat flag.txt, and there we go. Unchecked negative index into got overwrite goes burr. So fun challenge.